Hello, Jean-Pierre. I am going to go through the energy questions you have to do. I'm not going to tell you the answers. I'm just going to help you work them out. The only one I haven't been able to do, and there might be a few others that I don't know how to do, is the first one, unfortunately. I don't really understand the question, so let's skip it for now. If you know it, great. Um, so let's start. So a cyclist freewheels from the top of a hill, gathers speed going down the hill, and applies his brakes and eventually comes to rest at the bottom of the hill. Which one of the following energy changes takes place? So is it potential energy to kinetic? Potential to kinetic to heat? Is it kinetic to potential to heat? Is it chemical to heat to potential energy? Or is it kinetic to heat to chemical energy? So you have to start from the beginning and you have to divide the situation in steps. So he's freewheeling from the top of a hill. He's gathering speed. He's applying the brakes and he's coming to rest at the bottom of the hill. Which energy changes is he going through step by step? Think about it a bit. So now we'll go to the next question. So in loading a lorry, a man lifts boxes each of weight 100 newtons to a height of 1.5 meters. How much work does he do in lifting the box? We know that work done is equal to force times distance. So how much work does he do? You have the force and you have the distance. So you can work it out. Work done equals force times distance, and you choose one of these. Now, if he lifts 4 boxes per minute, at what power is he working? Now we know that power is equal to work all over time. So if he lifts 4 boxes per minute, at what power is he working? Now, we know that to find the work done, we know that work done equals force times distance. But we can't use the answer of over here because in the first answer, we only did 1 box and over here he's asking you for 4 boxes. So you have to times this by 4. You have to find the work done for 4 boxes, so 400 times 1.5. And then you have to use power equals work over time. You have to find the answer of the work done, which is 400 times 1.5 all over the time. So it says per minute. How many seconds in a minute? I'm not going to tell you the answer. You should know it. Hey, Mela. That's what you have to do for this. Question 4. A boy whose average weight is 600 newtons runs up a flight of stairs 10 meters high in a time of 12 seconds. Find the power he develops. So, this question has 2 parts. You have to find, first of all, the work done. And then you have to find the power. So, as we have seen before, work done is equal to force times distance. So, you have the force and you have the distance. So, the first thing you have to work out is the work done because just a second. Because we know that power equals work done all over time. So first we have to find the work done, which is 600 times 10, because it is the force times the distance. And now for power equals work done over time. So you found the work done, so you do 600 times 10, and then you do that all over 12 seconds. So divided by 12 seconds, because power equals work done all over time. So you divide those things and you find the answer. Now the answer has to be in watts. It's either this or this. Now these you're going to have to reason them out on your own. You have to see what kind of situation he's giving you. So a slice of bread. What kind of energy does a slice of bread have? So you have kinetic energy, which is movement energy, you have potential energy, you have chemical energy, which is found in food, you have heat energy, you have elastic potential energy, you have electrical energy, you have magnetic energy, and you have sound energy. Which of these is a slice of bread? And you have to do the same thing for all these. So the next question, a pole vaulter has a mast. A pole vaulter has a mass of 50 kilograms. Now what is her weight in newtons? We know that weight is equal to mass times gravity, and gravity is always 10. So we have to do 50 times 10, and you have to find the answer in these three. So 50 times 10, because weight equals mass all over our weight equals mass times gravity. So mass 50 times gravity 10. And you have to see which is the answer. Now, if she vaults to 4 meters high, what is her potential energy? We know that potential energy is equal to mass times gravity times height. So, if she vaults to 4 meters high, what is her potential energy? Oh, since we already did mass times gravity, we did mass times gravity in the first one to find the answer. So we can use the answer of this and times it by 4. That's what you have to do for this. So the answer of A times it by 4, and you have to find the answer from these three. So, how much kinetic energy does she have just before reaching the ground? So we know that to find kinetic energy, it is half times the mass times velocity squared. Now, I just realized this is a trick question and you're going to have to figure it out on your own, but I can give you a hint. Energy changes from one form to another. So potential energy is changing to kinetic energy, but the answer stays the same. So the answer of this basically is the answer of this. That's all you have to do. Now, what is her velocity just before reaching the ground? Now, for the last one, we know that kinetic energy is equal to mass times velocity. I can't do the squared symbol, but it should look like this, okay? So you have squared over here. So I'm going to just do 2. I hope it doesn't confuse you, but this means that the V is squared. So we know that the kinetic energy is 2000. Just a second. Equals. We know that the mass is 50 kilograms. Sorry, I didn't realize you couldn't see it. Yep. So kinetic energy equals mass times velocity squared. You know that the kinetic energy is 2000. You know that the mass is 50 times v squared. So 50 times, if you take it to the other side, what does it become? Division, it becomes division. Division by 50 equals v squared. Now, 2000 division by 50 is 80. Wait, just a second. Sorry about letter D, but I actually don't know how to work this out, so either work it out on your own or leave it out. Don't leave it out actually, at least choose one of these. Let's move on. This one I don't know either because the question is Galileo drops a stone from the Leaning Tower of Pisa, which is 45 meters high. At what speed does the stone hit the ground? Now, the only Oh, I think that this is a trick question. I'm not really sure, so try figure it out on your own, and I hope you get it right. Question 8. Silvan is doing pull-ups at the gym. Silvan has a weight of 800 newtons. During one pull-up, he moves up to 0.5 meters. So he's moving 0.5 meters. Now, calculate the work done. We know that the work done is force times distance. Now, we have the force. We have the distance. But he's telling you 10 pull-ups. So what do you have to do to the answer? I'm not going to tell you. So for one push-up, he has a weight of 800 newtons and he moves 0.5 meters. So we have to calculate the work done for one pull-up, is 800 times 0.5, which is 400 joules. Now he's asking you 10 pull-ups, so that was for 1. Now you have to do it for 10. So what do you have to do? I'm not going to tell you the answer, because you can do it. Now calculate the power developed by Silvan if it takes 35 seconds to complete 10 pull-ups. Mela, you found the work done found in A. So we did force times distance and then the answer times 10. Now calculate the power developed by Silvan. Now we know that power equals work all over time. You know the work done from the answer of A, and you have to divide the answer by 35 seconds because because power equals work done all over time. This is the equation. And you have to find the answer between these four. So you have to do the answer of this divided by 35. Mela, question 9. Calculate the kinetic energy of a 1 kilogram trolley traveling at 2 meters per second. Now you know that kinetic energy is equal to half times mass times velocity squared. So half times the mass times 1 times velocity squared times 2 squared. And you work it out and the answer should be either one of these four. Now, calculate the kinetic energy of a 2-gram bullet traveling at 400 meters squared. For B, all you have to do is use the same formula, half times mass times velocity squared, but you have to change the 2 grams into kilograms, and the way you do this is by dividing 2 by 1000. So divided 2 by 1000, you use this formula and you have to find the answer for B. You can do it, yeah? You can work it out. All you have to do is half times mass times velocity squared. You have the mass, you have to change it to kilograms, division by 1000, and you have the velocity, which is 400, and you can work out these. Number 10. A motor is used on a building site to raise a block of stone. The weight of the block is 720 newtons, and it is raised 20 meters in 24 seconds. Now calculate the work done on the block. Now you know that work done equals force times distance. You have the force and you have the distance. So you can find work done in question in A. It's either one of these three. So now calculate the useful power supplied by the motor. We know that power equals work done all over time. Now you found the work done in question A. And what you have to do is the answer of work done all over 24 seconds. So the answer of A, division by 24, and you'll get the answer, one of these three. I'm going to stop the video here and I'm going to upload a new one, another one to add on to this, okay?